This is my evolutionary world. In this world live creatures that, through evolution, develop intelligent and diverse behavior. The creatures have 2 eyes, 2 eyebrows, a mouth for biting, a cube-shaped body, and absolutely no idea what they are doing. It's a brutal world. If a creature doesn't find food fast enough, it starves, collapses, and leaves behind a pile of remains for other creatures, especially those creatures with a newly developed taste for meat to happily consume. But even random behavior can initially, when there's no competition, be enough to produce offspring. The offspring inherit their parents' DNA with a chance of slight mutation, allowing different behaviors to slowly evolve over time. An egg. Let's see what hatches. As we can see, the offspring has similar behavior to its parent, but walking backwards is a bad strategy. Also, these are pretty much the only 2 creatures left. Out of the initial 3,000 creatures, not a single one was good enough to produce offspring that were able to survive and continue the lineage. Evolution has spoken loudly, so we'll have to restart the experiment. But before we do that, allow me to introduce Grandpa Studs, who will introduce you to the different grids in our ecosystem.
In this vast, beautiful, yet dangerous and unforgiving ecosystem, there are 3 different types of grids. The first is the plains, which grow the most plants of all grid types and serve as an essential food source for plant eaters. The second grid is the forest. It produces slightly less food, but contains trees that can provide cover from predators. However, these trees can also be dangerous obstacles that creatures can easily become stuck in. The final grid is the desert. It is an empty plain with very little plant life. This grid is especially dangerous for plant eaters as they risk starvation, but it can serve as a food source for scavengers or other predators, since starving creatures may leave behind remains for them to consume.
So, how do we achieve intelligent behavior and go from this to something more like this hundreds of generations down the line? First of all, the creatures have a few actions they can perform. They can decide how fast they want to move and in which direction. They can also decide whether they want to reproduce and whether they want to bite. In addition, creatures have several physical parameters. Veganism controls how well they can break down plants, where a value closer to 0 allows them to break down meat instead, and potentially allows omnivores to exist. A creature's jaw can also have different strengths, which determine how much damage it can deal, with a value of 1 being the highest. Finally, flat teeth help with eating plants, while sharp teeth allow them to eat meat and deal more damage to other creatures. So now you might ask the question, why not just max out everything? First of all, a creature can't have a full set of sharp teeth and a full set of flat teeth. The sum of the 2 values can never exceed 1. The creatures also have an energy reserve, which prevents them from endlessly speeding around the map. Biting also requires energy, and the stronger the jaw, the more energy each bite consumes. This reinforces the need for creatures to conserve energy and avoid biting when food is far away. However, to achieve intelligent behavior, we must set up a proper environment. We can't just spawn a huge amount of food. That would make all strategies, good and bad, viable. It would also encourage creatures to develop only flat teeth, since that would be by far the best strategy, leaving no room for other behaviors such as predation. Each grid tile has its own energy system that caps how much food can grow on it. When a tile has a lot of plants, new plants spawn faster. When there are fewer plants, new plants appear more slowly. This forces creatures to move around to find new food, as they can't simply stay on a single tile. As creatures develop more intelligent behavior, the population will naturally fluctuate. Food levels decrease as tiles are cleared out and increase again once enough unfit creatures have died off, allowing time for plants to regrow. But just like what happened to the dinosaurs, we also need to introduce events that impact the ecosystem in different ways. These events increase diversity by forcing population fluctuations. I'll let Grandpa Studs explain that part.
Context. In this ecosystem, we have 4 different types of events. The first is the purge event, which causes a random number of tiles to lose all plant life. Next is the bloom event, where a random number of tiles grow as many plants as possible, capped by each tile's individual energy reserves. The final 2 events have less immediate effects. One causes plants to regrow faster, while the other causes plants to regrow more slowly.
In order for a creature to reproduce, it must have a food reserve of at least 2. Once the creature reproduces, it loses that food reserve, taking a risk to create new generations of potentially better evolved creatures. But which parameters can mutate? First of all physical parameters can mutate. Also, the parameters change ratio and the learning rate can mutate, deciding how many and how big the mutations should be to its offspring. For example, in the early stages, large behavioral changes may be required, but in the later stages, smaller adjustments may be necessary in order to fine-tune and not completely change already existing behavior. But in the end, it's up to evolution how that plays out. The most important mutations occur in the creature's brain. Let's dive into that for a moment. The creature's vision consists of raycasts or lasers that fire outward and report to the brain what the creature is seeing. Let's see this in action. This is what we see, but this is what the creature sees. All the creature sees and all the brain receives are numbers between 0 and 1, which it must use to decide what to do. Each vision vector corresponds to an individual raycast. Each vector contains 13 values, representing the following. Can the object we just hit move? Is it alive? Is it dead? How much health does it have? Is it plant-based food? Is it meat-based food? How strong is its jaw? How sharp are its teeth? How flat are its teeth? Is it immovable? The last 3 values are the normalized x, y, and z coordinates of the object in the world. With that in mind, which object do you think this raycast has hit? Let's look at another example and see if you can figure it out. What do we see here? The final vector contains the creature's own parameters, x, y, and z coordinates, remaining energy, fear, also called a memory neuron, a neuron that is calculated and then fed back as input when the next decision is made, health, food reserve, and finally which type of food its stomach prefers. These values are then sent to the creature's brain, which is a large neural network. First, the vision values are processed, producing an output. This output is then combined with the creature's own parameter input and processed one final time, where the brain calculates an output vector. Each value in this vector corresponds to a decision such as speed, rotation, multiplying, and so on. The neural network brain contains about 26,000 parameters, meaning that to make a single decision, the brain must perform more than 26,000 calculations. Each of these individual parameters can mutate and evolve, allowing for great diversity in behavior. Initially, all these parameters are randomly initialized, so you can expect most creatures to behave very unpredictably. To be fair to them, they don't know what's going on. However, a few creatures may by pure chance move forward, and if luck is on their side, also bite continuously, allowing them to eat food if they stumble upon it. If a creature eats enough food, it can reproduce, but this decision is also affected by the brain. A creature may be fit to survive, but if it doesn't reproduce, its lineage will be lost forever. As a result, many random parameters must align for a generation of more intelligent creatures to emerge. This also highlights just how amazing it is that life exists at all. In the beginning, it was essentially pure coincidence. I let the creatures simulate for thousands of days, and here are the results. The creatures have now evolved for more than 5,800 days, and just look at how intelligent they have become. Their individual lifespans have become much longer as they are far better at detecting food, even in environments with little food, as in this case. Oh, it's moving toward trees. Let's see if it can avoid them. And yeah, it actually does. In day 1, this creature would have been dead and would not have been able to get out of the situation. And there you saw it again, it avoided the tree. Very nice. If you haven't guessed it already, the creature we're following is a predator, identifiable by its red coloration. As a result, its stomach has evolved to process meat far more efficiently than plants. Also, this creature seems to prioritize dead remains. See there, it just avoided a herbivore. It avoided the fight, probably because it's a risky move to engage in a fight. It might die. And when there is no food available, even predators will sometimes eat grass, and there it just engaged in a fight and actually got another predator. Now look at this herbivore and how fast it eats plants. So the herbivore's teeth has evolved more towards eating plants. The most incredible thing is that all these creatures we see are actually descendants of a single creature from the very beginning. This means that at some point in evolution, the species tree branched out and one branch moved toward predation. And there we go. We now have an ecosystem where all kinds of species can evolve without me forcing any specific behavior, unlike traditional machine learning methods. It's unknown how many individual species exist, but we've achieved the full range from herbivores to omnivores to predators. I hope you enjoyed this video, and I look forward to sharing more of my progress.